This module on control plane fundamentals defines the control plane and explains the role of multi-protocol BGP, or MPBGP, and route reflectors in the Versa Secure SD-WAN control plane. At the end of this module, you will be able to describe the control plane, explain how MPBGP is a control plane protocol, and describe the function of the route reflector in a BGP control plane. The control plane is the process used to distribute reachability information within a network. With an SD-WAN, the control plane is used to discover the information required to set up network overlays. It is used to define how secure tunnels of the overlay are built, how traffic is separated and secured from the data plane, how traffic in the tunnels is abstracted as bundles that expand and extend over any combination of transport fabric choices, and how the industry-recognized capabilities of MPBGP are leveraged to provide high-performance routing convergence while still retaining the security of IPsec. Let's discuss how MPBGP is used as a control plane protocol. Overlay networks commonly use MPBGP as a control plane. MPBGP is an extension to the original BGP routing protocol that is used throughout the world to interconnect corporations and service providers over the public internet, and also within corporations and data centers to manage large amounts of routing information. The MPBGP extensions to BGP allow the addition of new route properties that can be associated with prefixes. BGP speakers or devices that establish BGP sessions with each other negotiate which properties are supported when they build their sessions. This ensures that MPBGP speakers are compatible and that the devices are capable of exchanging the same types of routing information. Versa Controller is the control plane manager of the Versa Secure SD-WAN solution. Versa Controller is the centralized route and reachability distributor within the MPBGP domain and acts as a BGP route reflector. BGP route reflectors are perhaps the most commonly used method of distributing routes within a BGP routing domain, from enterprises to data centers to service providers. The goal of the route reflector is to receive the BGP reachability information from clients or other BGP speakers and reflect those routes to all other BGP clients within the BGP domain. Implementing a route reflector topology increases scalability and centralizes control of where routes are received and to where routes are advertised. BGP is used for routing between independent routing domains. The Internet is the most common example of the use of BGP. The Internet consists of thousands of organizations throughout the world. Each organization routes and forwards traffic within their network domain according to their own policies and rules. However, they must coordinate with other organizations in order to route and forward traffic to destinations outside of their organization. Autonomous System Numbers, or AS numbers, can be public AS numbers or private AS numbers. Public AS numbers are used within the public domain, such as the Internet. Private AS numbers are reserved for use within an organization. Whenever a prefix is advertised to a different organization, the advertising router adds its local AS number to the AS path property of the prefix. In this way, the path towards a final destination can be tracked as it is advertised, and loop prevention can be enforced to avoid prefix advertising loops. BGP routing is used in Versa Secure SD-WAN to propagate customer site information throughout the SD-WAN routing domain. When a CPE device, such as a VOS device, receives a BGP route from a remote CPE, the properties of the route are analyzed and the routing policy places the route within a customer-facing VRF based on the route properties. BGP routing updates consist of a set of common parameters and a list of prefixes that share those parameters in the update. The same prefix can exist with different parameter sets, and therefore the prefix can be received from more than one device, once for each set of properties, and the local device can select the preferred version of the prefix for forwarding to the remote destination. Click the indicated link to see an example of BGP routing. When routes are received by the BGP process in the Organization Control VR, the routes are analyzed and sorted according to their route type, or NLRI, and other properties such as community values. Standard IPv4 routes are placed in the Control VR main routing table. Routes that are received that are of the Versa private type are placed in the Versa private route table in the Control VR. Customer routes that are received are sorted according to the VRF target communities. Once the target VRF has been identified, the route distinguisher is removed from the prefix, and the standard IPv4 prefix is placed in the customer LAN VR VRF table as a BGP route. These routes in the LAN VR VRF table are the routes that represent remote sites that are reachable through the SD-WAN overlay. Versa private routes are BGP routes that are unique to the Versa Network's SD-WAN solution. Standard BGP processes are used to advertise a special route type with properties associated with the SD-WAN environment. These routes are stored in the Versa private routing table. If you look at the example on the slide, you'll notice that the Versa private routes don't list an IP prefix, but have information associated with a router ID or a node in the network. Some of the information associated with each node in the network includes the global tenant ID and route types. Other information that is carried in the route can include circuit information and encryption key information, which is not displayed by the show route commands. The IPVPN routes are stored in the L3VPN.IPv4.unicast routing table and can be viewed using the command shown in the image. Both the received routes and routes sent from the device can be viewed. These commands show the customer LAN routes sent and received by the VOS device and include the extended communities, VPN label, and route distinguisher information. The extended target community is what is used to identify into which customer VRF the route should be placed. The VPN label is used for data plane forwarding and indicates which label should be placed in the header encapsulation in order to have traffic forwarded to the prefix. The Layer 3 VPN route process used in the Versa Network's control plane is the same Layer 3 VPN process used by service providers and enterprises globally for MPLS Layer 3 VPN services and is a proven and scalable technology. Because of this, the Versa Secure SD-WAN control plane inherits all of the stability and scalability of this process. The diagram shows how the virtual routers, or VRs, and the virtual routing and forwarding tables, or VRFs, are associated within the VOS software. Routing policy is used to propagate routing information between VRs and VRFs. The LAN VRF in the example is owned by the corresponding tenant control VR. When multiple tenants are configured, each tenant has a control VR with corresponding LAN ports. Each transport network resides in a transport network-specific VR and can be shared between tenants. If a tenant has a private WAN service that is dedicated to that tenant, then only that tenant is linked to the transport VR and it is not visible or usable to other tenants. The transport VR provides the source and destination IP addresses between the external WAN interfaces and does not contain any customer-specific information. You have reached the end of this module. In this module, you learned that the control plane is the process used to discover information required to set up network overlays. Overlay networks in service providers and enterprises commonly use MPBGP as a control plane protocol. Versa Controller is the control plane manager of the Versa SD-WAN solution. BGP routing is used in Versa Secure SD-WAN to propagate customer site information throughout the SD-WAN routing domain. When routes are received by the BGP process in the Organization Control VR, the routes are analyzed and sorted according to their route type or NLRI and other properties. And Versa private routes are BGP routes that are unique to the Versa Network's SD-WAN solution and are used for topology discovery and management.